Good day everyone. So for today's video, we will going to talk about the geometric sequence. So how to solve the geometric sequence. So by simply multiplying the terms or the previous terms by a constant ratio, then you will be getting the following terms. We can only determine the following or succeeding by simply identifying a particular constant that would result in the succeeding or the next terms. So we have here two examples of geometric sequence in finding the ratio. So our example number 1 is 20, 40, 80, 160. So in finding the ratio, we will going to divide the second term and the first term, and by dividing them we will get the ratio, and that the ratio of our example number 1 is 2. So if we will going to solve it, if we will multiply the 2 in 20, the answer is 40, and if we will going to multiply the 40 into 2, the answer is 80, and if we will going to multiply the 2 in 80, we will get the 160. That is that we call patterns in geometric sequence, okay? By multiplying the ratio that you get in the given geometric sequence, okay? So in our example number 2, we have negative 8, negative 8, negative 8, negative 8, and negative 8. So in multiplying the ratio, just like what I have said before, we will going to divide the second term and the first term, which is negative 8 divided by negative 8, and the answer is 1. If you will multiply the negative 8, the first term, which is negative 8, into 1, the answer will be negative 8, and that will become and so 4, okay? So that is on how to solve the common ratio in geometric sequence. Now let's move in our parts of our in finding the last term, the formula in finding the last term in geometric sequence, okay? So the formula in finding the last term in geometric sequence is a sub n is equal to a sub 1 r raised to n minus 1, okay? That is the formula in finding the last term in geometric sequence, okay? So a sub n is our last term, and a sub 1 is our first term, r is the common ratio, and negative 1 is the position of the segments or term that is being looked for, okay? So we have here two examples of geometric sequence for us to understand on how to solve the last term and to how to find out or solve the common ratio of the given geometric sequence, okay? So I will going to talk to you on how to solve it. So we have here two examples of geometric sequence on how to find the ratio, okay? So this is our example number 1, and this is our example number 2, okay? Always remember that we can only determine the following or succeeding by simply identifying a particular constant that would result to the succeeding or the next term, okay? So always remember, if this one if we will going to multiply that or find the ratio, okay, let's find first the ratio para mas maintindihan, okay? So in formula in finding the ratio is r is equal to a sub 2 divided by a sub 1. This is the formula in finding the ratio in geometric sequence, okay? So let's try this example number 1. Our a sub 2 is 40. Our a sub 1 or our first term is 20. Okay, so if we will going to divide that, the answer is 40 divided by 20 is equal to 2. Okay? So that is the answer. Okay? So the ratio of this given geometric sequence is 2. Okay? Para mas maintindihan nyo, this if this 20, you will multiply it in 2, the answer is 40. It is the same in 40. If you will multiply in 2, the answer is 80. If you will multiply the 80 into 2, the answer is 160. In this way, we can see that there is a pattern. Okay? Okay. In this way, malalaman din natin kung yung given ba ay geometric or arithmetic. Always remember, if the given is arithmetic, it is positive. It is addition. Okay? But if the given is geometric sequence, it is multiplication. Okay? Okay po. So, let's move in second example, which is this one. Okay? So, what I have said in the first example, the formula in finding the ratio is a sub 2 divided by a sub 1. In our second example, the a sub 2 is negative 8. So we will going to write here the negative 8 divided by our first term, or a sub 1, which is negative 8 again. So negative 8 divided by negative 8 is equal to 1. This is the ratio of our second example. Okay? This is the way and formula on how to find the ratio in geometric sequence. Now we will going to move in example in finding the last term in geometric sequence. I have here two examples that we will going to solve. Okay, so first, okay, a sub 10 is our last term that we will going to find, or we will going to solve. Okay, the formula in finding the 10th term, or the last term in geometric sequence, is a sub n is equal to a quantity r raised to n minus 1. Okay, so this is the formula in getting the geometric sequence. Okay, and rather in finding the last term of geometric sequence. Okay, so a is our first term, r is our ratio, and n minus 1 is the position of the segments or term that is being looking for. Okay, so an is our last term. Okay, so the n, we will going to change it into 10. Okay, so we will going to simplify it. Okay, so our a is a sub 1 is our first term, which is 7. Okay, oh, I forgot, we were going to solve the ratio for us to solve the last term. Okay, so in getting the ratio, we will going to write first the formula. Okay, so this is the formula in getting the ratio of the given geometric sequence. Okay, so we will going to write the formula, which is a sub 2 divided by a sub 1. So our a sub 2 is 21 divided by a sub 1 is 7. Okay, so 21 divided by 7 is equal to 3. So 3 is our ratio in this given geometric sequence. Okay, so we will going to write here the 3 because it is the ratio. So raised to, what is our n? 10. Okay, so 10 we will going to write here the 10 minus 1. Okay, so a sub 10 is equal to 7, then 3. We will going to subtract this first before we will going to solve the other. Okay, 10 minus 1 is equal to 9. Okay, so a sub 10 is equal to 7. Okay, so we will going to solve this. Okay, 3 raised to 9 is equal to 19,683. Okay, this is the answer here. Okay, so a sub 10 is equal to, we will going to multiply it na. Okay, so 7 times 19,683 is equal to 137,781. So this is the answer in our example number 1. So the 10th term of this given geometric sequence is 137,781. Okay, so let's move in our example number 2. Our example number 2 is here. The missing last term is a sub 15. Okay, so this is the missing last term in our example number 2. So first we will going to find the ratio. Okay, so the ratio is a sub 2 divided by a sub 1. Again, our a sub 2 or our second term is 24. So 24 divided by our first term, which is 6. So 24 divided by 6 is equal to 4. This is our ratio in example number 2. Okay, now we are going to find the fifth term or the last term of this geometric sequence. So we will going to write the formula for us to be guided. So a sub n is equal to a sub 1 quantity r raised to n minus 1. Okay, so our n is 15, which is our last term, and our first term, a sub 1, is 6. Okay, now our ratio is 4 raised to 15 because 15 is our n minus 1. Okay, so we will going to rewrite the 6 and we will going to subtract it first. Okay, before we will going to other step. Okay, so 15 minus 1 is 14. 4 raised to 14 is equal to 2, 6, 8, 4, 3, 5, 4, 5, 6. So this is the answer here. Okay, this is the answer here. Now we will going to multiply it to find the last term or the fifth term of our second example. Okay, so 6 times this one is equal to 16 and 27. Okay, so this is the answer um, in second example in geometric sequence. Thank you for watching, and I hope you learned and you enjoy our lesson for today. God bless.